Hello, algebra students. Today we're going to be covering the Unit 6 activity. So hopefully you have it open already, but if not, go ahead and do that. And let me go ahead and share my screen with you guys, and we can start working on that. Okay. So hopefully you're right here. It looks like this. When you get to here, click on this, and then go to Use Template, and then that should give you this, and then you'll be able to edit this document. So there's one other thing we need to open for this activity, and that's the Algebra Tiles online. The link is right here. So you can go and click on this, and then click right here, and then it'll open the link for you. And it should look like this. Now when you're here, notice on the left, there's all these little things you could drop down. Go to the Algebra Tiles one. So you want to go to Algebra Tiles, and then it should look like this. All right, so those are all the things you kind of need to have open for this thing. But now let's go ahead and start talking about what they're talking about here. So if you notice the first one, it says, review what you know about products and sums represented by rectangular area models. So if you took the first semester online, then hopefully this will seem somewhat familiar, but if not, that's okay. We'll go over this. So it says use the algebra tiles to multiply x minus 1 times 3x plus 2. So here's how we use the algebra tiles to do that. So we got x minus 1. So I'm going to need an x, and I'm going to need a minus 1. So you're going to go and put those next to each other just like that. Now, since I want it to be x and a minus 1, to make one negative, just go ahead and click on it. So now this is like x minus 1. And you can do that with x's as well. If you click it, okay, but we want that positive. So x minus 1. Then we also have 3x plus 2. So 3x plus 2, and these are going to go on the top, and you'll have 2 unit tiles. Now, to make these things, you're going to want to make these things like switched, like that. So we want 3 x's next to each other like that, and then plus 2. So now we have the two things we're going to multiply together, and then we're going to fill in this rectangle. And whatever we fill in the rectangle with, that's the product. So that's what we get when we multiply. Now you can kind of see the x times the x, you get this square here. You can see kind of there's like a square spot. That's going to be where the x squared goes. You see x times x produces x squared. Another x squared goes here, and another x squared here. So we're just filling in this rectangle as best we can. Now you could see, hopefully you could see that an x would fit here. Now this is a negative 1 times x, so that's going to make this a negative x. So go ahead and click on that to make this negative. X times negative 1, x times negative 1, just like that. Now over here we have an x times 1. Well, that's an x. And another one here. And then lastly we have this little spot here. So this is 1 times negative 1. So these will both be negative 1. So now we can see this rectangle here is the answer to what happens when you multiply x minus 1 times 3x plus 2. And so the answer would be 3x squared. I'll go ahead and write that down on my whiteboard here. 3x squared. And we have a negative 3x and a positive 2x. So in total, that's a negative 1x. So I'm going to put minus x and then minus 2. So this is the product when multiplying x minus 1 times 3x plus 2. And again, it's this rectangle that kind of fits in with the algebra tiles here. Okay. Hopefully that kind of makes sense. Now, in order to put this into the answer sheet, you should go ahead and take a screenshot. If you have the snipping tool available, that's very useful. And you just take a snippet of that, copy, paste into here, and it looks very nice like that. Even make that a little shorter. And that's part of the answer. And there you go. It says, all right, so it has an instructional video. You could watch that if you want. But basically, we're going to try to factor this thing. And what that means is we already have the answer. We already have the middle portion, this section essentially. We just need to figure out what goes on the outsides. So let's go ahead and recreate this. So we have x squared, and then we have 5 x's, and we have 2 units right here. And we need to figure out what's going to go along the top and along the side. All right, so I'm going to go and recreate this. So I don't need this. If you want to delete anything, just take the algebra tile and drag it over to the side here. And that'll just delete it. Okay, pretty sure that's how it looked like. Oh no, I added too many. Get rid of these. Get rid of these. And then 2 unit tiles right here. Okay, so here's the rectangle we're working with. And our goal, again, this is the product, essentially. So our goal is to figure out what 2 things multiply to give us this. So let's think about what would go along the top here. Well, you can kind of see that it would be an x times another x times a single. You see? X, and single. So yeah, it makes the same distance here as this here, the same width of this rectangle is this wide. 2x plus 1 wide. Similarly, along the bottom, or sorry, along the side, x, and then 2 units, just like that. So what 2 things multiply to give us this? In other words, what 2 things multiply to give us 2x squared plus 5x's plus 2? Well, it would be 2x plus 1 times x plus 2. In parentheses, x plus 2. And again, we can go ahead and take a screenshot of that, copy and paste it over, and a screenshot of this. That way you can put in the answers nice and neat into here. Okay. So that's essentially what we're going to be doing. We're going to be building these rectangles and then figuring out what the factors are along the sides that give us this rectangle as a product. So let's do another one together. So we'll do a couple of them together, and then I'm going to ask you to do a couple of them on your own as well. So let's go ahead and work on this first one together. So, and also, sometimes a rectangle can't be built. You can't make a perfect rectangle out of it, and that means that it's not factorable. And I'll show you which ones those are. But let's go ahead and work on this one. So we got 2x squared plus 7x plus 6. Okay. So I need 6 singles. I'm going to make 6 singles here. And we need 7x. So we have 5x's here, 6, 7. Okay. So I've got 2x squareds. Now the x squareds, when building a rectangle, the x squareds are always going to go next to each other. And then the x's are always going to go either along the side or along the bottom to try to make this rectangle. Okay, so I'm just kind of thinking, how is this going to work? I can just start building it, and maybe it'll start working out for me, and maybe it won't. Maybe I'll have to rearrange things. But okay, this looks pretty good. But can I fit all these singles in here? Well, no, I can't. See, these singles are left out. So maybe I don't want to build the rectangle like this. So I'm going to move these back out of here. And how else can I do this? Well, instead of putting 6 down here, maybe I could take a couple of these and put them along the side here, like that. Oh yeah, that works. So now we can put these singles just like this and put them along like that. Do you see how that makes a perfect rectangle? Hopefully that kind of makes sense. And sometimes you're going to have to rearrange it a few times to see how the rectangle will work. But again, sometimes the rectangle is not possible to build. And I'll go over that. All right, so now that we have our rectangle, now we want to put what goes along the side and the top. So along the left side, we have an X, and then looks like 2 singles. So one of the things we're multiplying is X plus 2. That's one of the factors, X plus 2. And then along the top, the other factor, 2 X's, you can see that there, 2 X's, it looks like plus 3. Just like that. Okay? So, again, you would take a screenshot of that, and you'd want to write over here as well the factors. So X plus 2, and then 2X plus 3. X plus 2, and 2X plus 3. Okay, so again, take screenshots, post those onto here, and that's good. Okay, let's try the next one. 6x squared plus 7x plus 2. So we're going to need 6x squareds in this case. And 7x's plus 2. So I'm going to get rid of some of the stuff. All right, I've got my plus 2 here. And we need 7x squared. So I'm going to pull in 7 of these x squareds and put them next to each other. And move these x's out of the way. Or sorry, 6x squareds. My bad. 6x squareds. Like so. Okay. Plus 7x plus 2. Well, it's possible these might go like this. Or it's possible these are all lined up like this. So basically we need to make a rectangle just out of these. And there's really only 2 ways to do it. We could either make it a 1x6 rectangle or a 3x2 rectangle like that. Let's see what we could do with it like this. All right. I want you to see if you can build the rest of the rectangle on your own. This looks correct. Well, let's see. Maybe like this. These can go maybe here. Yeah, like that. Okay, cool. Now we've built the rectangle. All right, cool. That's how the rectangle is going to look. Now I want you to put in the x's along the top and along the side, the x's and the singles, however many you need, along top and the side. And again, we went over a couple examples. See if you can figure out the rest of this so we can figure out the factors for the top and on the bottom. Or sorry, top and on the side. So see if you can figure out those factors by putting the algebra tiles along. Okay? I'm going to leave the rest of this one up to you. Let's take a look at the next one. So once you've done that, I mean, you could pause the video, work on that, and then I'm going to move along to the next one. All right, next one. X squared plus 4x plus 1. So x squared 4x, and a 1. I'm going to go and get rid of the rest of this stuff. So I got an x squared, I've got 4 x's, and I've got a single. Now, how can I make a rectangle out of this? So let me maybe just try moving these things around. Well, would this work? This formation? Well, no, only one thing can't fill in this whole gap. Won't fill in this spot. And there's no way I can think of a couple of things. We've tried 2 and 2. We've tried putting 3 and 1. And we tried putting 4 and 0. And there's nowhere to put this in any of those situations. There's nowhere to put this to make this a perfect rectangle perfectly. So what do we say? Well, we say we could show this. I would go ahead and take a screenshot of that and put it into the work. And you can type that this one is not factorable. This is one of those ones I was telling you guys that sometimes the trinomial won't be factorable. So this is one of those. So this trinomial, not factorable. And the reason why is because we weren't able to use these terms to make a perfect rectangle. I am not able to put these terms into a perfect. And you can go ahead and show that by taking this screenshot and putting it there as well. All right. Next one. This one's a little bit interesting because it has x's and y's, and also it has xy's. So notice it has 2xy plus 6x plus y squared plus 3y. So there's a lot of things going on, but let's see if we can factor this thing. So first we have 2 xy's, and you can see the xy's are right here. So we got 2 of these. We have 2 y squareds. Or sorry, a single y squared. We have 6 x's and 3 y's. Okay. So now our goal is to make a perfect rectangle using these things that we have here. Well, let's start with the y squared. And then we can maybe either put both these like this, or we could put one like that. Well, if we put them like this, then we would need an x squared to go here. Well, we don't have an x squared to work with, so that's probably not an option. So I'm just going to put both these together like that. Now these y's would have to go along the y. Okay, that looks pretty good. Let's see if these x's will fit in here. Yeah, it looks like they will. These 6 x's will fit perfectly to finish off and make this a perfect rectangle, just like that. Okay, cool. That wasn't so bad. So now what are the factors though? So what would go along the side here? It looks like a y and an x and another x. So that makes the perfect height. The height of these three together makes the perfect height of this rectangle. Along the top, we have a y, and it looks like 3 singles, just like this. Okay, very good. So our 2 factors would be y plus 3, and also if you can, write down the whiteboard and take a screenshot and put that as well. Then the other factor is y plus 2x in parentheses. Okay, that's that one. Okay, Now these ones are going to be a little bit trickier because they have negatives involved. And I'll show you kind of how that's going to work. But it's not too much different and it should make sense. And like I said, you could change any of the algebra tiles to negative simply by clicking on them once, and then it'll make it like a negative algebra tile. Okay, that goes for all of these. It's going to play a role in this one here. So we have x squared minus 3x plus 2. Let me go ahead and get rid of this stuff. We got an x squared minus 3x. So since it's minus 3x, these three x tiles, we're going to go ahead and negative them, click on them to make them negative. And then we have plus 2. But the same rules apply. We want to make this into let's see. Okay. We want to make this into a perfect rectangle. So maybe we do like this. Ah, yeah, that looks good. That's not too bad. Now, the tricky thing is, how do we figure out what these factors are that go along the side and the top? Well, hopefully you can see that this x times x produces this x squared. Okay, we have an x times x produces that x squared. Now, and we have singles that go along the top here, and one single here. Okay, that looks good. See how this length is the same as this, and this height is the same as this height? So that's how you know you have it correct. But these are negative x's. You see that? And this is a negative x here as well. So how do I make sure that this turns into a negative? Well, it'd be positive x times a negative 1. And this would be negative as well. So this would be x times negative 1 to make that a negative x. X times negative 1, make that negative x. Should this one be negative also? Well, it's x times negative 1, yes, to make that negative x. Now that should make sense because down here, these are both positive. These positive unit tiles, which makes sense because it's a negative 2 times a negative 1. A negative times a negative gives us positive 2. See? So negative times negative gives us positive here. And that's why these are negative, but this is positive. So this is our image that we want to place on there. And then our factors will be x minus 2 and x minus 1. So make sure to include that as well. All right. This next one's going to be also kind of tricky, and I'll show you why. So we have 2x squared plus x minus 6. So in this case, we have 2x squareds. We have a plus x. Get rid of this stuff. Get rid of this stuff. So we have 2x squareds. We have a positive x. And we have a minus 6. Let's go ahead and add in 6 single tiles. And since these are, turn them into negative unit tiles. All right, so these are the things we have to work with to make our rectangle. Let's see if we can make it work. So I can't put the x down here because I only have a single 1. I'll have to put it over here. But then do these singles really make it work? Doesn't look like it. So I can't fill that in. I can't fill it in over here. It's kind of not the same perfect length. Well, there's a trick to this, and it mentions it right here. It says you can add a 0 to it. So if we add like a positive x and a negative x to this, so if I add an extra x and an extra negative x, I'm actually just adding a 0. Now that might show you what I mean. So let's go ahead and move those out of the way. Now that I have this negative x, maybe the negative x can go here. And these positive x's can go, since I have two of them, can go here. Maybe I'll add another 0. Now, I can do something like this. And maybe add one more 0. Perfect. So notice what we have here. We still have 2x squared, and we still have plus a single x, because these negative 3x's will cancel out with 3 of these, and we'd still be left with 1 positive x. So we should still consider just have 1 positive x here. Even though I added all these others, we still just have 1 positive x. Okay? So that's a little bit trickier. But now that we have that, we can easily see that these unit ones fit in perfectly to fill in the rest of this rectangle. Great. Now I'm going to leave it up to you. Figure out what the factor would be that goes along the left and the factor that would go along the top. Okay, we've gone over a few of these, so see if you can figure that out. Finish the rest of this one. Take a screenshot, add it to the answer sheet. All right, we've got a few more to factor. Let's take a look. So this next one has x squared minus 8x plus 15. X squared minus 8x plus 15. So we have 8 x's. We have 15 singles. We just have a single x squared. These are negative 8 x's. These are all negative. And we have positive 15 singles. So let's move in all those unit tiles. So that's 10, 14, 15. Okay. So let's see if we can make a perfect rectangle using these here. Well, one of the tricks we can kind of use, since I know this is 15 here, I could think about what two things multiply to give me 15. Well, in our case, it's just 1 times 15 or 3 times 5. Well, let's see if I can organize these in such a way that I can get that 3 times 5. So I could put maybe 5 of these down here, and then the last 3 of them along the side here. Now this gap is a 3 by 5 rectangle, right? 3 by 5. And so it would take exactly 15 of these unit tiles to fill it in, which is perfect. That's what we have. We have 15 of these guys. It's there. Just like that. Okay, see if you can tell me what the factors are that go along the top and along the side. Once you have those factors, once you've put in the algebra tiles that go along the side and along the top, finish this up, then copy and paste it, the screenshot, put it here. All right, next one, x squared plus 7x minus 8. In this case, we have 7 x's. And we have minus 8. So I'm going to get rid of a bunch of these. And let's see if I can figure out a rectangle that adds up like that. So plus 7x minus 8. Well, if we think about that minus 8, how can we form that minus 8 into a rectangle? We could do a 2 by 4 rectangle like this, or an 8 by 1 rectangle. With these 7, let's see, would that fit in perfectly? Not quite. Well, maybe if I move one of these here, would that fit in? Would these guys be able to fit in perfectly? No, can't fit in that gap. What if we move another one up here? Will these guys fit in perfectly? It doesn't appear so, right? So it doesn't look like this is really working very, very well. If we put all of them together on just like the bottom right here or along the side, this won't fit in to make a perfect rectangle either. It looks like there's nothing that's going to work to make this a perfect rectangle. And basically the reason why, and I could just kind of look at this equation or this trinomial, and I could already kind of tell that there's no way I could factor it because I'm looking for something that multiplies to give me -8 and adds up to give me 7. Well, maybe we have to add in a 0. Try that. Now I could put in this down here, this here, and this here, and this one here, and add in all of these like so. Ah, it looks like it is factorable. So again, we have to use that old trick of adding an extra 0 worth of x's so that we can fit in all our singles. So it looks like our factors will be x minus 1 and then x plus 8. Okay? So make sure to show the algebra tiles that go along those, x minus 1 and then x plus 8. And then take the screenshot, put it right there. Last one. Now this one might not be factorable because I know they're going to at least give us one that's not factorable. But let's take a look. X squared minus 5x minus 1. X squared minus 5x minus 1. So I just have a minus 1. Get rid of these. We have minus 5x's. And we have a minus 1. Okay, so let's see, is there a way I can organize these to make this a perfect rectangle? So that doesn't work. How about if I put this here? Well, that's not going to fill in either. Okay. So the 2 and the 3 doesn't work. The 1 and the 5 doesn't work. Or 1 and 4. And the 5 and 0 doesn't work. Okay, well maybe I can add in some zeros. Maybe I could add in a 0 here. Now the thing when you're adding a 0 is the negatives all have to go together and the positives all have to go together. So it'd be like that. Now can this fill in this gap? No. Well, what if I add another one? Now can this fill in this gap? No, now it's even worse, right? So even adding zeros to this, it doesn't look like there's any way for this single unit to fill in this rectangle, whether we add in extra x's or not. So this one's not factorable. Okay, so I want you to explain that this one is not factorable. And again, like we explained before, where we said there's no way to form, put the terms into a perfect rectangle. Basically the same explanation. And even if we added the plus and minus x to it, to change it up a little bit, that doesn't allow us to do that either. Okay? All right, well, I hope that all made sense. Now, if you have any additional questions, if you still need help with this assignment, feel free to send me an email. Again, you should know it by now, but it's ttrig@ofy.org. That's ttrig@ofy.org. And I hope that made sense, and good luck. And I'll see you next time.